Well, hello again everybody, and today I'm going to be doing an unboxing video. Now I don't normally do unboxing videos, so this is I guess a bit of a first for me. So what I've got here, it's a battery operated drill, and the make and model, it's a Tacklife PCG01B, and it's described as a power tool or a rotary tool. Now it's rechargeable this, and it's got a voltage rating of 3.7 volts, and it's got a number of speed controls. So it says the first speed is 5,000, the second speed is 10,000, the top speed is 15,000, and it also says it comes here with a range of collets, and it says it's suitable for charging with a 5 volt USB charger, and it's made in China. So let's open it up and have a look inside. I'm kind of hoping that it's actually going to be charged up, because this is going to be a bit of a boring and a short unboxing video if the batteries are flat, aren't they? Ah, okay, so it doesn't come with a charger, but it comes with a little USB lead. Nothing very exciting about that, just a standard USB lead. I always forget what they call those connectors. Is that a mini B that size? I'm not sure. We're not going to read the instructions because it's a drill. How hard can it be? Oh, it comes with a warranty card. Yeah, I can't see that being a lot of use. Here's the instructions. It's a drill. It comes with some probably quite useless accessories. Let's see what we've got in here. So what have we got? Oh, I've got some little cute little drums, little drum sanding wheels. That looks like that's the what do you call that? It's not a collet, is it? Don't know what you call that. That's the I assume that's the bit that the drums slide on. Yeah, okay. Actually, that feels okay. Actually, what have we got here? We've got some felt. I think that's felt. Is that felt? Yeah, that's felt. We've got a hard felt polishing mop. That's very hard. We've got a little rotary brush. I've got a few drill bit. Oh, that's a drill bit. Feels sharp. We've got a little rotary burr. I forget what they call that. They call it a bell end burr or something. That little round carbide burr. Don't know if it is carbide. Could be high speed steel. Who knows? Feels sharp. Looks okay. Got some of these little compact, compressed grit abrasive wheels. They're typically totally useless. Got another little abrasive wheel. In fact, it's got a set of different shaped abrasive wheels there. Got another little polishing mop. Actually don't feel very soft them. It's actually quite a hard material, whatever it is they're made out of. What else have we got? We've got, oh, just feeling that. That's what they call that's a diamond burr of some description. So that's some kind of tool that's been dipped in hot zinc, then dipped in diamond powder so that the diamonds coat it. So again, some kind of grime wheel. Got another of those little diamond wheels. In fact, there's a host of those little diamond tools here, and generally what these kind of very cheap and nasty diamond tools have in common is that they're always totally useless. The diamonds just fall off them. They're not correctly bonded onto the piece of metal, and I don't know, you assume the diamonds are very hard, but they're no good because they just fall off. I mean, I haven't tried it, but they're going to be rubbish. But I didn't buy it for the crap accessory kit, so let's move that out the way. And let's have a look at the main feature. First impressions, it feels very plasticky. It actually looked a lot better in the advert. I probably should have said earlier I bought this from Amazon, and I think it was about £20. And the reason that I bought it is I don't know if you remember in the video last week where I was repairing a CB channel select switch. I actually used my soldering iron to actually melt a hole in the top of it because I didn't have a drill to hand. I actually did have a Dremel. I've got one of these little Dremel tools in the garage, but it was raining outside and I couldn't be bothered to go out in the cold to find it, so I just used the end of my soldering iron and bodged it. But having done that, I'm wondering if it is a good idea to drill a hole in the side of a switch body, because, you know, if you've got any bits of powdered plastic or something, you do run the risk of, you know, getting all that grit and filth into the casing. So maybe my idea of just melting the hole in the plastic wasn't a bad idea. Anyway, I had some spare time at work and I was bored and I needed to do some retail therapy, so this is what I bought. So first impressions, it doesn't creak, it feels quite solid. It feels okay, like I say, maybe a little bit plasticky. I'm guessing that's the on and off switch there, so yeah, without any further ado, let's just try pressing it. Okay, and it comes on. That's 2, that's 3. Oh, seems relatively easy to stall. That's quite clever. If you do stall it, it's obviously got some kind of current detection, because if I stall the motor, oh, it did it before, maybe the battery was going flat, it did actually cut out before, it's not doing it now. Oh yes, it does. So if you've got it on high power and you stall the motor, it's got some form of current limit and it automatically cuts out. So yeah, that's quite handy, isn't it? I can hear my cat whinging. What's up, cat? What's wrong? What's wrong with you? Come here. Come on. Yeah, cats, eh? Come on, come and be on the video, cat. Come on. Cat, you're an idiot. She's being quiet now. No, she's not. Shut up, go away. Go on, bugger off. Bugger off. Right, okay, we're going to carry on. I'm sure the cat will keep whinging in the background. First impressions, yeah, it's a drill. It's certainly not as good as a Dremel. It's not as powerful as a Dremel, but then again, it doesn't cost as much as a Dremel. I guess the thing is, let's see if we can drill a hole in something. Well, I've already been having a little bit of a practice. I've got this this diamond burr installed on here, and I'm just going to try on this FR4 material. I've already had a go and it did a good job. I'm just going to put some water on here because the last thing I want is to be breathing in FR4 material. In fact, what I think I'll do is I'm going to go over the copper, and then we'll cut into we'll go through the top layer of copper, and then we'll go into the FR4 material underneath. So I'm just going to put some drops of water on there, because the last thing I'm going to be doing is breathing in lots of shards of fiberglass, because that wouldn't be fun, would it? So I think we've just got through the copper layer there. And now we're into the FR4 now for sure. Okay, so this is a little crater we've excavated, so you can see we had the copper layer there, and then we had the FR4 there, and yeah, it had absolutely no problem going through that. I don't even know if it's charged up very well, this actual drill. I've just using it out the packet, so if maybe it was charged up, it was even better. I was on the highest speed using the diamond burr, but yeah, short work, it cut through it like butter, very easy. Now there is a little bit of method to the madness here. I'm not just damaging circuit boards for the fun of it. Sometimes when you've got a damaged track, and especially if it's a multi-layer board, it's not unusual to actually have to grind down the top layer of the circuit board to actually get to the track that you want to get at. Maybe you've got a burnt out track or a bad via on a multi-layer board, and you can often find yourself having to grind through the top layers to actually get at it. It's not something you do very often, but you know, I have done it on more than one occasion. Actually, strangely enough, I've usually done it when I've been prototyping, because yeah, I've made a mistake with my pin out or something like that, and I've been trying to just bodge something to get a prototype working, so I'm afraid I've had to do that more than once. But it is quite handy to be able to just cut tracks and things like that, or maybe create a little bit of separation. Yeah, for example, let's just see if we can just remove this track here. So let's, again, I'm going to put a drop of water in. The water does two things. It lubricates the diamond bit, stops it from getting hot, because if you're using a diamond tool, the enemy of diamond is heat. It's heat that ruins your diamond tools. It's not actually they go blunt, it's that the heat makes the diamonds fall off the substrate. They tend to be bonded to the metal underneath using something like zinc, and basically zinc melts at a relatively low temperature, so if you get these very hot, the diamonds just fall off. So let's turn that on again. Let's see if we can, well, I'm not going to say surgically remove, let's see if we can get rid of this track. It's a bit too much water there, can't see what I'm doing. Okay, well that took absolutely no time at all. Again, I'm not saying it's a great job. I'm forcing things a little bit to find ideas to do at the moment, but you know, necessity is the mother of invention. Okay, so we did have a track there, now we don't. Of course you could just cut it with a Stanley knife and put your soldering iron on it and peel it off with a Stanley knife. That's probably the way to do it. That's the way I certainly would do it if I didn't have a grinder. Yeah, sometimes when you're doing rework on a PCB it is necessary to do a little bit of grinding. This diamond burr I'm using, it's quite aggressive. Let's try and use maybe that drum sander. See if we can do, you know, a better job with removing some of this conformal coating and the solder resist. Maybe we can remove a bit of that without maybe making such a mess of the copper underneath. Okay, it bogs down a little bit using this drum. Again, short work of that. I had, you know, absolutely no problem doing that. Took a couple of seconds. Again, not the sort of thing you're going to need to do very often. I'm kind of thinking that this is the tool you might use. Have you ever worked on I don't know, vintage televisions and very old valve radios where you might want to be wanting to solder onto the chassis and you've got 60 years of accumulated crud and filth and rust, you know, and stuff like that, contamination. You just want to grind through the surface quickly in a small area so you can tin it and solder it. So yeah, I can see myself using one of these little drums to do that. Yeah, one type of common repair that's quite often done is you will find maybe a track that's burnt out like that. I don't know, an area's burnt out. I've just put a piece of black pen on to represent the burn. And what you'll find is if the track has burnt out, that area is now loaded with carbon. It's carbonised, and carbon's a conductor. So if you was to repair this track, there'd be no point in just putting a jumper across it. That would be an easy thing to do. But if it was you know, something a bit more complicated, we've got quite a few tracks running next to each other, you'll find that this burnt area, this conductive layer, you would get signals creeping to adjacent tracks through this burnt layer of carbon. It would be quite a common thing to do, just to excavate around that piece of carbon. You would remove all the carbon, all the damaged material, all the FR4, and then you backfill it with epoxy, and then you put the new track over the top of it. There's some very good videos that show that done via paste. They show you the correct way to do it, but I've done it loads of times using this self-adhesive foil that you can buy. I think they even sell it at garden centres for deterring slugs from your strawberries. But basically it's got a self-adhesive backing, and what you can do to repair a track is the old track you can just break it away, scrape it off, and then you just put a new piece of track on it and put some solder on it, and Bob's your uncle. So I've just been and found some of that copper foil tape that I was talking about. You can get it in lots of different thicknesses. This stuff that I've got here, it is actually quite thick stuff. You can get much thinner stuff, but yeah, so that is a very thick track. So imagine this track here had it was actually totally burnt out. what you would do is we would use our rotary tool, and we'll just grind it away. I'm going to use that diamond burr again because that seemed to work quite well. I was cursing these diamond burrs earlier, wasn't I? But this one seems to have done okay. And I'm sure that these things would cost nothing if you bought them from China on eBay or something like that. I'm sure you wouldn't pay any money for them. So let's just excavate that out. So what you would do is you would basically just keep grinding away at the material until you'd removed all the burn. So you're not just removing the damaged track. You actually need to remove all the black material, all the burn from around it. And you'd also clean up a little bit of the track around it. We've ground out all the charred mess, and depending on how bad the damage is, you might actually have to go all the way through the board, in which case you actually have to find a bit of scrap FR4 board. You cut it to shape and you actually then epoxy it in over where the damage is. What we would normally do with this, if we were doing a proper repair, we would take some epoxy resin. Now they make special epoxy resins which are designed for circuit boards. I've never used that. I just go to Poundland and buy the cheapest stuff I can, and I've found it works fine. So what I would typically do now is I would actually build up that hole with epoxy resin, and then we would go in again with the Dremel or the tool, and we would grind that flat. So we've removed all the FR4 and we've got a nice flat material. I'm not gonna bother doing that epoxy stage for no other reason than I can't be bothered to do it at the moment. But what I will do is I'll get a little bit of flux. It's in my iron. And what you need next, of course, is a data book, because what we're going to do is we're just going to take a bit of our copper foil and we're going to cut some of it off it. I'm going to, obviously, if you really cared about what you're doing, you'd make some effort. But basically, we cut this down to the thickness of track that we want. So remember, if we were doing a proper repair, this would be going on top of fresh, clean epoxy. Now it wouldn't be going directly onto the hole you'd excavated. You'd probably fill that in. But having said that, if you didn't really care and it was not a particularly high frequency board, it really wouldn't matter. So I've just trimmed the end of this now. And again, if you look at the people who do this for a living properly, they'll give you lots of details here about what you should actually do is you should actually, when you grind away into the material, you should actually create an undercut, a lip. And what you can do is you can actually feed the copper foil underneath the track that's permanently there. I'm not going to do that. I'm just going to bodge it because I'm a bodger, aren't I? But that's what you would do. You would create an undercut so we could slide. You could slide the new piece of copper foil. You want to be able to slide it underneath the existing track. And of course, it doesn't help at all that I've tried to stick this material down onto the board, which is still soaking wet. So yeah, that's why the copper isn't sticking. But you get the idea, don't you? So I'm going to try and cut the other side now. Well, here's a close look at the board where we've just done a little quick and dirty track repair. Now, of course, the objective here wasn't to show you how to repair a trace on a board, although you could pretty much do it in a similar way. What I was actually trying to show you is just the capabilities of this little mini drill and the sort of things you could do with it. So there's a quick and dirty example of that. Now, having stated how crap this cheap and nasty little repair is, let's see if we can test it to destruction. So there we go, 20 amps. Okay, that's been on about 5 minutes now, and it's just starting to warm up, but actually the wires are getting hotter than the trace repair. Okay, so we've done some grinding and some excavating. I think it's about time we actually see if we can drill a hole, so let's try drilling. It's going through that like I would say hot butter. It's going through very easily. Now one of the little complaints I've got, it's got this, what would you call it, this rotary lock here. You press this button here and it stops the drill from rotating, with the idea that you can unscrew the collet and get the drills out. But unfortunately it does come to hand a little bit too easily, this. I keep putting my thumb on it, and for some reason, because it's a button, I keep pressing it when I try and switch the drill on and off, when the actual on and off control is at the back here. So that's kind of an only minor complaint. I mean, it's very good that it's got this little collet lock here, but it's not so good that that you press it so easily. It'd probably be better if it was a little more recessed, not such a nice push button. So the main on and off button is there. I don't know if I said that earlier. And it's got 3 speeds, and those are indicated on these red LEDs. So speed 1, speed 2, and top speed. Now I've just noticed here, it does feel as though maybe this end piece unscrews. So I think that, okay, does that unscrew or does that just pull off? No, it does unscrew. So a lot like the Dremel tools that you might be used to, it looks as though you could actually install this into some kind of a drill stand if you wanted. Now I've only just spotted it now for some reason, but I think I understand why this board originally failed. You can see that at some point it's been infested with PCB worm. Because you can see here the little holes here where the adult PCB worm, where it's actually, you know, burrowed its way out of the FR4 material. So yeah, I guess I could do with spraying this. The other thing you can do is, if you have got a PCB that's infested with worm, just leave it in the freezer overnight and that will kill them. Now I was joking, of course. Don't put PCB boards in the freezer. That won't do anything to kill the worm. You need to put them in the microwave. Now hopefully I said at the beginning of this video, the main reason that I bought this little PCB drill was actually I wanted to drill a hole in top of a relay. Well, actually it wasn't a relay, it was that switch, or the channel change switch on that CB I was looking at. Because what I actually did was I drilled a hole in the top of it, and I sprayed in some contact cleaner, but what I used to drill the hole was the hot tip of my soldering iron, and I don't actually like abusing my soldering iron like that. I prefer not to do it. That's why I bought a drill, but I have kind of had second thoughts about drilling a hole in relays and stuff like that, because I think you probably stand a chance of getting your plastic and contamination inside the relay. You drill through it and some plastic swarf is going to drop in, and that might not be a good idea either. So perhaps you are better to actually melt a hole with a tip of an old soldering iron, something like that, to get some contact cleaner in. Because if you melt a hole, you're not going to get those particles, those swarf dust being created. It's just going to melt its way through. But I guess if you are going to drill some holes through it, the other thing you could do is, and what you do on stuff like car bodywork or sensitive equipment, is you actually cover the end of the drill bit in grease or Vaseline. So what happens then is, when you actually drill through, any particles or swarf, they stick to the grease on the end of the drill rather than dropping inside. So that's a little trick if you do want to minimise how much dust or dirt can drop inside. Okay, I did that, and I did actually see some bits of plastic go inside, which is what I kind of feared. Some bits of plastic dust did drop inside, but they did actually fall to the very bottom of the relay, so maybe that's not an issue. So we've got the straw inside, and let's give it a bit of a spray. Now, I think I said in the earlier part of the video, it doesn't come with a charger, but it does come with a USB charge lead, so you'll have to provide your own USB charger. I'm not exactly sure how much current it pulls from the charger, but I charged it up. I used an iPhone charger, which can deliver, I think, more than an amp if it needs to, if it negotiates, which I'm sure this doesn't. But this charged up in about an hour, but I'm not sure it was completely flat. But it did manage to do all the drilling and grinding operations that we did today on, you know, as it came out the box. So I suspect the battery life is more than sufficient for again, average occasional use, no problem. So all things considered, I actually quite like this little Tacklife drill. It's perfectly suitable for doing PCB rework and modifications. I probably wouldn't like to drill hundreds of holes in a PCB with it, simply because you really want a drill stand, something that will hold the drill perpendicular to the circuit board, because you are inevitably going to put some side loading on the drill, and when you're using these very small PCB drills, which aren't much more thickness than like a human hair, really thin drills, they snap so easily. So if nothing else, you're just going to break a load of drills, and that will be annoying, and they can get quite expensive when you just break one after another. Somebody who has spent a lot of years breaking PCB drills, I know what I'm talking about here. So you know, if you're going to drill lots of PCB drilling, you're going to etch your own boards, invest in something like a Dremel with a stand. But I actually think that this has got some advantages over a Dremel. It's very light, it hasn't got a wire hanging out the end, so it's not pulling you back. It's not too powerful, so it's kind of good that because it's not too powerful, it's a bit safer, it's a bit slower. Because it hasn't got that huge electric motor inside, it's got a small electric motor, you don't get that torque effect when you start the motor up. You don't feel it pulling you around, so it's quite easy to manipulate. So when I was grinding away at the PCB before, you know, that kind of operation, you hold it just like a pen. You can't hold a Dremel in the same way, you've got to put your whole hand around it. Now, I'm not downing Dremels, I've got a Dremel myself, it's great, it's very useful, but for little fine PCB work, I actually think this is probably better. If you want to buy these, they're not very expensive. I think this one was about £20 from Amazon. I'll put a link onto the video if anybody's interested in getting these. But there's a whole host of drills like this and similar ones. They're all cheaply manufactured in China, and yeah, there's nothing wrong with it. So I guess until next time, that'll do. Thanks for watching. See you again soon. Bye for now.